Hello everyone. In this video I want to look at the question: find the vertices, foci, and equations of the asymptotes for the hyperbola y squared over 144 minus x squared over 25 equals 1. So in finding all these parts of the hyperbola, it's important to identify my a, b, and c for this particular equation. We can do so by considering our general form. The general form, when we have y squared first, is y squared over a squared, x squared over b squared. Recall with hyperbolas, a squared and b squared are always going to be in the positions you see here. A squared is always going to be first, b squared is always going to be second. It's the x and y that change. So in this case, y being first, the a squared is 144, and b squared is 25. That also means when y squared is first, this particular hyperbola is oriented along the vertical axis. Of course, if x squared had been first, it would be oriented along the horizontal, or what's also called the transverse axis. So to identify my vertices, foci, and eventually my asymptotes, we find a and b. A is 12, b is 5. We use the general equation a squared plus b squared equals c squared to find our value for the foci. So I have 144 plus 25 gives me 169. So that means c is going to be 13. This time I'm able to take the square root and it works out evenly. Now that I have all these values for a, b, and c, identifying the foci, vertices, and asymptotes of the for the hyperbola, we can just refer to our general equations. Again, because it's a y squared and x squared alone in the numerators, we can assume the center of this hyperbola is at 0, 0. And then our vertices and hyperbola have this general form. So with a being 12, now we have 0, 12 and 0, negative 12 as our vertices. Our foci, our focal distance, I should say, at 13 gives us 0, 13 and 0, negative 13. And with b again being defined as 5, my two equations are y equals 12 over 5x and y equals 12 over 5, I should say negative 12 over 5x. Remember, the equations for these hyperbolas, or for these asymptotes, come from the central box that is always constructed with the hyperbola, this distance of a, from this distance of b, and I should reverse this since we are oriented along the vertical axis. Here's my a, negative a, b, and negative b. So the asymptotes we talk about go through the center, through the corners of the central box, and helps us to eventually construct our hyperbola.